Thank you for having us. We did have a couple good conversations on the piping side of things, and we're really excited to be a part of this and excited to be here. And thanks everyone for spending an hour over your lunch with us. I'm Phil, and on the line with me, I have Ben Bowman. He's going to be doing a little bit of demonstrating in Creo today. And we have a couple topics on the agenda. I think number one, we just want to give a very quick introduction to CADactive, just so that you understand how we might be able to help with some of your Creo challenges. And then we're going to talk through a few tips, best practices, did you knows about Creo in regards to model performance and assembly management. We'll talk through some of Creo's out of the box functionality that you may or may not know about, show how we can help with some of these topics, and then we'd love to open it up and answer any questions you have at the end. Feel free to put questions in the chat if you'd prefer. We're also happy to make this a discussion if that makes sense. So let's jump right into it. So we're CADactive, and we're a PTC technology partner. We help companies all over the globe to improve the way that they use Creo. We help with a combination of automation software built for Creo and some of our extensive industry experience. Here are a few of our customers. A lot of different sizes, shapes, industries, profiles. And so we identify and solve some of the most common issues they're facing with Creo. Just like this broad range of customers, I know you all on this call build different types of products and have different philosophies about how you design. We think that the principles that we're applying with our automation are super flexible and can be applicable to a lot of different use cases. So some of the topics that we typically address, first and foremost, just task automation, kind of removing that click, click, click heavy nature away from Creo. Model performance is a big one that we're going to focus on today, making sure that the work that you all are doing isn't devalued because your model is unusable or inaccessible. Data connectivity, making sure that data that you're putting in your model is automatically flowing through the entire process, not just in design, but downstream. We hate manual translations and manually updating, so we try to remove as much of that as possible. For a lot of companies, it's manually. I think about bringing in maybe ECAD data. You got to have your wiring diagram on one side of your screen and Creo on the other side, and you're kind of component by component going through and adding these in. Try to get rid of that as much as possible. And a big way we do that is through data fidelity. We're big believers in encouraging our customers to build complete, high fidelity, consistent CAD models for a few reasons, right? Number one, it's better to uncover mistakes and errors in CAD than it might be to do so downstream. And number two, we know that the better your digital product definition in CAD, the easier it is to move towards some of those more cutting edge Industry 4.0 capabilities. Again, we're a PTC development partner, which means we can develop applications that run within Creo. A couple quick things about the platform. We typically end up focusing on the more advanced and challenging issues in Creo. For instance, routed systems design is a frequent source of frustration for our customers, so we become experts in it. Topic of today's conversation is complex assembly management, which is inherently tied to routed systems design, but has a lot of other useful applications as well. The CADactive automation platform is built using the Pro and Object toolkit functions, makes it super easy to deploy, handle, use. We handle all the maintenance and updates to our application. We build it all the way back to version 4.0. So our application is also continually evolving as we address challenges that our customers are facing. We're always striving to kind of improve the application. So when we add features or make enhancements for one customer, our entire customer base are beneficiaries. Just a very quick note on how we think about improving design processes for our customer. Since we've worked with customers all over the world, of all shapes and sizes, we've seen a lot of different starting points. Some may be further along than others. And we have a lot of customers that may come to us and say, hey, we're looking to build a model from Excel, or we want to automate our drawing creation process. And while that's all great and we can help with those types of things, we find that a lot of customers maybe need to start at a more fundamental level. And that can mean synchronizing the team and getting them on the same page with something as foundational as maybe settings and configurations in your Creo environment, making sure that we're all starting from the same point. Then we take it kind of a step further and start standardizing the data that we're putting into the model. Make sure that there is complete and consistent information and rules that the design team is really following as they go and build the products. And once we have that really nice foundation, we can go play by some of those rules with automation and do some really cool and flashy, cutting edge stuff. We also specialize in routed systems, like I said. It's a big piece of what we do, just because it's so challenging for a lot of folks in Creo. And we've also built a custom reporting engine where we can go and kind of extract information out of Creo as needed. So without further ado, I'm going to kind of jump into the content of the presentation. I know that was a lot, but the main topic today is tackling model performance in Creo. We figured this is a really broad and commonly frustrating topic, so we're excited to walk through some of our best practices with you. Model performance becoming a more and more prevalent topic and source of frustration because companies are starting to put more and more information into their digital product definition and their CAD models. What's great about Creo is it's very well equipped to handle these complexities. That said, it's definitely not magic, and it takes some time and attention to do well, which is why we often talk about great assembly management being a really critical facet to any design team. So why is assembly management so important? We're hoping that you guys can all relate to some or all of these. Number one, downtime. Sitting around waiting for a model to load or open is obviously not productive or value added. Additionally, if you can't spin that model around and really manipulate it, it can be absolutely infuriating. Lost data and rework, pretty self-explanatory. Obviously, it's not good when Creo crashes. And it can be a massive source of frustration and duplicative rework, right? Issues with collaboration and concurrent engineering. Maybe you're stepping on each other's toes or designing over each other's work. Maybe there's confusion based on missing data in a model, or rework because you modeled something that was out of date, right? Or there's duplicative rework because information that should be included as part of maybe your library definition is not, or you have to manually add that information over and over and over every single time. And then finally, and arguably most importantly, is the value of your work. Challenges with assembly management often mean that some pieces of a product might not actually get designed in CAD. And if this is the case, then that incomplete information is bound to cause issues downstream. For the longest time, a lot of companies didn't design cable harnesses in CAD. You very seldomly saw it. Because it's difficult to do from an assembly management perspective. Over the past few years, we've seen a really big uptick in clients who we've helped build more accurate digital representations of their harnesses. If you're one of those, please reach out to us. But even if you do model every single piece of your products, it's important to be able to leverage that model elsewhere, whether that's manufacturing, downstream, fabrication, service, sales, marketing, quality. If the model is overweight, unmeshable, unopenable, not only is it infuriating to work with from a design perspective, but it can be detrimental to that downstream value. We all want to feel like we're adding value, right? So we have a few tips and tricks that we want to talk about today, as well as some automation that we'd like to show. And we're going to define some native features and functionality, and hopefully that'll give some good direction. But also working with clients all over the world, we've developed what we think is a really good perspective on best practices for complex assembly management. Oftentimes, they can feel like taking the long way around, and they can be very click heavy. So we're going to show some ways which our automation can help you do things the right way without having to slow down. So let's jump right into it. First and foremost, there are a few things you can do right out of the gates without much upfront effort that can meaningfully affect model performance. Number one, red in the model tree. Errors in your model tree can happen for a lot of reasons. And very few companies understand the real impact that this has on performance at any level. If you can fix the red in your model trees, you're going to see an instant improvement. Number two is understanding references. Once you've removed those errors from your model, it's important to understand how your model is referencing the different components within it, right? How can we trace what you're actually asking Creo to do when you bring a component into memory? So understanding those dependencies and reference paths can make a really big difference in how the model performs. And, yeah. Model check is PTC's way to establish and enforce design standards. We can help filter out bad CAD practices here. I'm sure you guys are all familiar, right? Things like orphan datums, buried features, circular references, and so on. Model check's great. The challenge with it is that it can be difficult to maintain and manage and configure and deploy. So we've seen very few companies that really get it into practice, just because it's driven by a set of complex, finicky backend text files. So if you're looking to implement model check or you're curious about it, we'd love to have a discussion. One of the biggest things that separates Creo from the rest of the CAD landscape are simplified representations, and they're stored within the master assembly file, and they allow you to only load certain portions of the assembly that you need. For instance, if I want to load my model without any nuts and bolts in it, I don't need to see those things. I can do it, right? Please note that in order to modify a simplified rep, you got to have the master assembly file in session, which is why we suggest managing these reps from a team level. And I'm going to stop talking. I'd love Ben to maybe give a little bit of extra background on some of the different types of simplified reps.
Yeah, absolutely. So there's really three that I want to talk about right now. And the first of those is one that everybody should be familiar with. It's master rep. That's just by default, when you open a model in Creo, you're in master rep. What that basically means is that we're going to fully load everything into the model tree. Or fully load everything that is in the model tree. So that's just a default rep, right? There's another default rep that I want to talk about, but before I do that, a user-defined rep, like Phil had mentioned earlier, user-defined would be where we are explicitly going in and deciding what to load into session and what not to load. He used nuts and bolts, right? That's in one example. What I want to talk about is what a lot of people would refer to as an empty rep. So this is really common for people to use whenever they're working with really large, massive assemblies, right? You have an empty representation that just excludes everything. And so where that can come into play, if you have an empty rep, then you can open an entire, let's say it's a satellite or something, some massive model. You can open that model instantly if you open it in empty rep. And then we can be a lot more explicit about what we need to work on, what we need to bring into session, right? So we can control what we're loading in order to improve our time and not have to sit there waiting on Creo forever. So that's a user-defined rep. The other default rep that's just in every model that I want to talk about is called automatic rep. Definitely an important one to know. So in older versions of Creo, like a long time ago, they had two different reps, graphics rep and geometry rep. What they've done is kind of blend these into what is now referred to as the automatic rep. And what that essentially does is it's only going to load in the minimum amount of information necessary to display that model. So when you first open a model, it's basically, if you open that model in automatic rep, you're basically going to be opening it in what used to be referred to as graphics rep, which is kind of just a graphical representation of the model. And then as you click on different components, Creo is going to dynamically load those parts or assemblies into session. So that's another great way to improve your model performance because it allows you to only fully load into session what you are actively needing to work on. Another thing, if you look at the bottom of that slide, we have a few different config options here. Config options are a great way to improve your model performance as well. There's thousands of these configuration options for Creo, so obviously it can be very overwhelming, but some of them can really make a big difference. We just have a couple listed there. So the first one, pre-highlight tree, that basically controls what is called pre-selection highlighting. So if you hover over a component in the model tree, should that then highlight in the graphics window or not? By default, this is set to yes, but whenever you have really large assemblies, that's a lot of thought going on in the background. So turning that off can bring some instant, model performance benefits. The other one we have mentioned there is open simplified rep by default. That's a great one. What that does, whenever you're opening a model in Creo, it allows a pop-up to show up. And I see the comment in the chat. And for now, I am not actually sharing my screen. I'm just going off of the slide here, but I will be sharing my screen in just a minute. So, but the open simplified rep by default, it allows a pop-up whenever you open a model in Creo, and it just gives you a list of all your simplified reps. So instead of opening in master, you can choose a specific rep or say that empty rep that we were talking about. And then the model will open in that representation. Now we don't have to load everything into session. So finally, another place where you can really see a lot of benefits, especially with large assemblies, is in drawings. There's a ton of different settings that you can manipulate and knobs you can turn in terms of Creo config settings for drawings. We've just got a link there that has a whole bunch of them, and we'll circulate this after the fact, so you guys can all dive into those if you'd like.
Awesome. So the first thing that we really wanted to show here was the CADactive Web Application. This is one piece of our automation platform, the other piece being the Creo interface, which Ben's going to show plenty of today. But this really talks to the synchronization and standardization pieces of process improvement, like I mentioned earlier. Let's get everyone on the same page, starting from the same place, including the same information in your models. And this web interface is meant to give a really simple and easy way to administer Creo. Right? We can manage all types of things in here. The first thing I'll highlight is the configuration manager, right? Like I said earlier, standardizing config profiles is a great way to get the team on the same page. So maybe certain config profiles are needed to be used for certain use cases, right? We might have a cabling profile that we deploy to our harness designers. Additionally, we can manage libraries in the web application. Gives an easy way to maintain, edit, deploy, in this case, a spec-driven piping library. We talked about piping in our last visit with you guys. Administrators can make changes to the library here, and the application automatically writes the files that drive Creo's spec-driven piping module. There's quite a different ways to organize and deploy the library, but it's meant to be really intuitive and give you an easy way to kind of control all these different facets of a library. Then finally, what we're going to talk about today a little bit are model templates. And model templates are meant to contain information about maybe what a good model looks like, right? For your use case specifically. I can establish traits, standard traits such as layers, orientation, sections, simplified reps, and I can enforce that the right metadata is getting included in the model. Maybe that's notes, maybe that's parameters. And we've configured this for quite a few different use cases, but what we've really built here is a use-based or a rules-based engine that allows you to have a lot more control and flexibility in how you deploy these standards. For instance, here's kind of a simplified rep engine, right? Rules engine. We can maybe create a rep that removes hardware. And it's an action to exclude certain components. And once we can set up rules around that components, and we can maybe find components by name, parameter, type, designation, a lot of different options to exclude from that rep, right? So this gives you a way to kind of automatically generate those simplified reps. And yeah, Ben, anything else you wanted to mention on the web interface? I wanted to kind of keep it moving quickly, but.
Yeah, the only thing that I would mention here is you'll see like that list of rules, right? Find part by subtype. If anybody's used the search functionality in Creo, you can access it by Control F. You can also do it if you're making a simplified rep. There's a way to get to the advanced rules there. We kind of mirror all of those different options that you would find there in our web app as well.
Yeah. So I think with that, we want to see how this looks in Creo itself. So I'm going to let Ben kind of share his screen and show how we will push these standards down into Creo.
All right, so everybody should be seeing my screen now. So here we just have a pretty simple model of an ECAD board, right? So if we look into the view manager, we can click through a few different things here. We have our orientations. I'm going to just straight up go and delete a couple of those right now. Now we'll change this one, do something funky with it and save over it. So now we have a couple different situations, right? We have some orientations that we're supposed to have that are not there, and we have some that are there but are not actually set up properly the way that they should be. So I click through, we just have that normal list of default simplified reps, some of which I was mentioning earlier. And then finally, let's click over to our sections. We have no section views on this model right now. So if I go to our CADactive tab in the ribbon and choose Apply Model Template, what this is doing right now is looking to the web app that Phil was just showing, and it's collecting all of the different templates that we have set up. And so here we have a list of those different templates. The ECAD board assembly template is pulled up by default. That's because this code has already been run on this model once before. So we store a parameter in there that basically says, hey, what was the template that we used? And then whenever we go and click Apply Model Template, we can pre-populate with the one that you've used on this model in the past. So if we look into the details here, we can see a list of all of the different orientations from that model template that we were looking at, right? There's the left and the right. They have a red indicator. Those are the two that I deleted. They have a red indicator because they are not in this model at all. Bottom and front have a yellow indicator because, well, I guess I didn't actually manipulate bottom on the call here, but it's not matching what should be there according to what is in our web application, in our model template. Same thing with front. That's the one that I manipulated and saved over. The other three here, back, top, default, they're showing as green because they're both in our model and they match what they're supposed to look like. So that's all good. Simplified reps, we're missing these three. You can see the red status indicator. Layers, we're all good. We've got everything we need there. And then sections, we've got the 3 section views that are missing as well. Finally, we have parameters here. There's a few parameters that are red. That means they're not in the model. What I really want to show here, though, is this type, which exists on pretty much all the things I've shown so far. So this tells you where these things are coming from. So a type of company means this is a part of your company standard. This is coming from the model template itself. PTC, these are going to be parameters like, these wind chill parameters, stuff that's put on the model by PTC. And then there's 2 more. There's CADactive. This is a parameter that we put on the model that we're going to use. Like I mentioned earlier, there's the CADactive model template parameter that tells us which one we had used on this board in the past. And then finally, custom. So you're obviously going to have a bunch of parameters on your models that are not a part of your model template, but that doesn't mean that they shouldn't be there. So with these model templates, we're not going to, it's additive, it's not subtractive. So you have a bunch of parameters already on this model. We're going to say, that's fine, you can keep those, that's all well and good. We're just going to label them as custom. And then finally, we have some other tools in the way of notes and relations. We can affect those as well. But what this comes down to, we can check boxes here and apply only specified things to our model if we explicitly don't want to add this parameter or this section or this simplified rep, whatever it may be. We can do that. Or we can just not worry about that, say we're bringing this model up to speed entirely, and say apply model template. And there you get a little sneak peek. You can already see the sections loaded in. But if I go back to the view manager, we'll see there's our section views loaded in. We now have our simplified reps. So if we look at ECAD board only, ECAD board summary, and then empty rep, all of these things have been added to our model along with our orientations. So our left and our right are back. They've been recreated, and our front now comes back into compliance with what it is supposed to look like. And I believe that's all I need to show. I think I can hand it back to Phil.
Sure. Just going to share my screen as well. Can you see that?
Yep.
Okay. Oh, wonderful. Hold on a sec. So we always focus on metadata and bolstering reusable data in models. It's something that I talked about earlier a little bit. So we want to kind of talk about some of the ways that we can use metadata to help from maybe a performance or a design communication perspective. So a couple definitions to start. I think we all presumably know what a parameter is, but few customers that we run into understand or think about some of the subtle differences in types of parameters. And we know that this is relatively simple, but again, you'd be shocked at how many folks are unaware of some of these concepts. So number one, a model parameter lives on a part in your library. This is standard information that should be included every single time a component is used, regardless of where, how, when it is used. Example might be vendor information or revision number of that part. Now, component parameters are applied to components in specific context of a specific assembly, right? So a designation is the most commonly used component parameter. These help us to distinguish between identical pieces of equipment in a model, right? They're called different things at different companies. I think tag number is another really common way to use this, but the idea is to avoid confusion. So designations should be unique to each and every component in the model, even if they're identical from a library perspective. And Ben's going to show a little bit more about this later. And then published geometry is a great example of a model feature that very few folks know about. Published geometry identifies critical interfaces, surfaces, and datums on some library part, and they can make your design process vastly more automatable and scalable. So once you establish a published geometry on a library part, it again makes everyone's lives easier moving forward. So again, I think Ben's going to talk a little bit about both of these and show a little demonstration about how we can help with them. Can you hear me, Ben? Did I lose
Yep.
you?
I was just
You're good.
going through the screen share process there.
Yep.
All right, so here is another model that we've got. The first thing I'm going to do is go into the published geometries like Phil was mentioning. So let's open up a library part here. So this is a typical component that, just a library part, something that you're going to bring in, you're going to get set up for, to be used by your company, and then it's going to be used all over the place in a whole bunch of different ways. What we're proposing is that published geometries should be a part of that initial library setup of this component. And then it's going to be something that's accessible to you every single time that every single instance of this component that gets placed, you have these published geometry features here for your use. And just to expand the tree, we have them organized here. We have some coordinate systems, we have some surfaces that we've published. And now I'll just show what that looks like in the CADactive Publisher interface. So on the left-hand side here, we have a list of all the things that are available to publish, all the different types of datums, On the right-hand side, we have a list of what has actually already been published. So there's our same surface group and then our coordinate systems. So I'm going to show how easy this is to set up. So what I'm going to do first is just delete all those published geometry features. They're gone from the tree, they're gone from the right side of my interface here. So now if I expand this out, we can see we have a collection of all the different planes in this model, all the different points, all the different axes, and all the different coordinate systems. So just to quickly recreate what we had before, to show how fast this really is, I could just wholesale say I want to publish every datum on this model, but you probably want to be a little bit more careful than that and more decisive. So I'll come in and just republish what we had, our J1 through J5 coordinate systems. Now we have 5 published geometry features that have not only been created, but they have been moved to the footer and grouped. The other thing that we had were surfaces, right? So it doesn't really make sense for us to collect and display those surfaces on the left side of the tree here. Just because there are several surfaces that are part of the same extrude. How do you know which one's which? And the number of them would just be so vast. So what we've done instead is we've offered this option for a new surface group. And now you can go and do a control selection of all the surfaces that you want to include. And what I'll do is just grab this surface down here. I can middle click. Now it's going to ask me for a name, and I'll provide that name. And there we go. Now we can see that we have our surface group. And again, it is organized and grouped into the footer. So now that we have our library part set up, we can come back to our assembly and start to talk about some designations, right? And as Phil had mentioned, designations are a way to uniquely identify which component is which, right? So here we have 3 of the exact same switch model. How do we identify which one of those is which? Because they have the exact same part name. Well, we do it with a designation. We have C switch 02, C switch 03, C switch 04. That way we can uniquely say, this is the specific instance that I'm talking about. If we go back into the CADactive tab and open up the designator, we can see a display of all of these different designations. From this window, we can designate something that's not designated. We can undesignate or edit designations. So this is a nice interface that makes it easier than it is to do this with Creo out of the box. However, where we think that we add a lot of value is this option to create a designation map. So I'm going to go ahead and do that. I'm going to open up in Excel my new designation map. So this allows me to work with those designations a lot easier in bulk using the tools that are available to us in Excel, right? I can write formulas, I can copy paste, I can, supply a number here, and then I can drag, or maybe that's a, test 1, test 2. That also allows me to drag and apply a whole bunch of these designations very quickly. Additionally, I can come in here and do things like copy paste. Whoops, there we go. And now once I've done everything I need to do in here, I get everything set up. And also just to explain this again, we have our feature number, we have our component path, and our model names. This all mimics the model tree exactly. So these are all just part numbers, but if we get into things that have names, it's a little bit easier to tell what's going on here. But this is just ordered in the same way the model tree is. I'm going to go ahead and save that file. I'm going to come back into our designator and I'm going to import the designation map. So now I can see here's a bunch of those designations. If I expand everything out, all of that came through properly, right? Here's the here's those ones that say test. That's all great. We can see the green icon next to them. That's because designations have to be unique. So a green indicator tells you, all good. This is a unique designation. It's not used anywhere else in this assembly. if I go ahead and collapse all, now we can see there's also a yellow status indicator. That's going to tell us this assembly right here contains a conflict within it. It's not designated, so it's not the conflict, but it contains a conflict. So if we go in and expand that, now we can see we have the red status indicator that tells us exactly where that conflict is, right? These two have the same exact designation. So that allows me now to edit my designation. As soon as I change that, this one will go green. We still have a red indicator here, so we have another conflict somewhere else in the model. I can see we have a yellow indicator there, so it's probably in here, and there it is. Again, I'll edit designation. And now that we have all unique designations, everything goes green. If I collapse everything, we have no yellow status indicators telling us that we have no conflicts anymore. Last thing that I'll note about this tool, this is great for designations, right? We can also set this up to work with a different parameter, like Phil had mentioned, that tag number. We have some customers who are using this tool with piping, and it affects their tag number instead of their designation. But we also have an option under tools to work with component parameters in exactly the same way. So we can export all of the component parameters in this model, in this assembly rather, and we can work with all of them at once in Excel. We can import that all back in. In that Excel file, if we wanted to add component parameters that weren't there to begin with, we can absolutely do that as well. Just add new columns. When you import it back in, it will create all of those component parameters in the model and assign the values to them as well. And with that, I will pass it back to Phil for tip number 3.
All right. We wanted to talk a little bit about lightweight representations as well. And Creo has quite a few different mechanisms for creating lightweight reps. And we want to talk about being strategic with how we create them. Like I said, this is one of the most robust CAD tools on the market. Creo is, if you use it correctly. And here's a couple features that you guys should know about. First, I'll mention bulk parts. They're a great way to lighten the weight and of your model. For instance, maybe we know that this standard piece of equipment has these 4 lag bolts and nuts and washers. So why would we need to actually model those and show those in our design? Let's just put them in the bill of materials, right? A lot of folks use these for things like paint or sealant or glue, maybe things that aren't one each. But configuring and using bulk parts correctly can certainly be confusing. And we have some automation that makes it a little bit more approachable. We're not going to go through that today, but certainly reach out if you're curious. Envelopes and shrink wraps are commonly used features that allow you to claim space for a given component in your model, but not load all of that detail into session. For instance, maybe for some design purposes, we might just need to know where the battery or where the control box is. We don't need all the fine detail of all the inner workings, right? Big time disclaimer here. These are powerful tools, but can be harmful or cause issues if used incorrectly. If you're thinking about implementing them into your workflow, we'd be happy to provide some direction. Skeleton models are one of the main features that separate Creo's advanced assembly functionality from other softwares. They can be super helpful when multiple engineers are contributing to a large assembly. They allow you to share a common set of references between multiple assemblies or systems without having to load all of those components of those higher level assemblies. So for larger models, CADactive's suggested best practice is to create a skeleton model of that higher level assembly and populate it with copy geometry for the more complex design tasks in relation to those higher level assemblies. So copy geometries, like I mentioned, are the references back to that parent assembly that live within the skeleton. And there's a couple different types, and Ben's going to talk about them.
Yeah, so quite a few users are familiar with copy geometries, but Not as many people are familiar with the differences between these types of copy geometries. So I think in order to understand the differences between these, first, it's really important to understand that when you're creating a copy geometry, you can really boil that down into two different parts, right? So there's first part is what are we copying? That's going to be your geometry, your datums, your surfaces, whatever it is that is actually being copied, the geometry, that is the what portion of this. The second piece of this is where. Where do we locate that geometry in space? Right? I have those features. I copy them into my skeleton model or wherever I'm copying them. But how do we now know where those should be located in three-dimensional space? So thinking about assembly context versus external copy geometries in that light, first we can look at the assembly context. These are fully associative copy geometries, right? So both parts of that, the what and the where, are going to be linked back to the source model in the context of this larger assembly. So this is a great option if you're going to create lightweight, fully associative models without creating some of those bad external references to the source model that can then, slow down your model performance, right? We're trying to lighten up those references. And again, just to reiterate, assembly context, both the what and the where remain fully associative. You have the option to change that, whether it's automatically updating, manually updating. You can switch it to no dependency. Obviously, at that point, it's no longer associative. But that is assembly context copy geometries. The second piece here, external copy geometries, are a little bit different. In this case, the what portion is still associatively linked to the parent or source model. If you take a surface and maybe it's a cube that's 3 inches by 3 inches, right? And you copied one surface of that cube. If you change that to be a 4-inch by 4-inch cube now, that the copy geometry, the geometry of the external copy geometry will update automatically. That will go from 3 inches by 3 inches to 4 inches by 4 inches. It's the where portion that is no longer linked automatically when you're using an external copy geometry. External copy geometries put the onus on the user to determine the location of the copy geometry in 3D space. So with those external copy geometries, you're losing a little bit of associativity, but you're gaining in terms of model performance because you're actually going to get a lighter weight reference here than even using an assembly context copy geometry. So assembly context is great, especially if you want automatic update. External copy geometries, even better in terms of model performance, but you lose a little bit of associativity there. And that is actually where our tools come into play because we have come up with a way to kind of try to get the best of both worlds in terms of creating external copy geometries and giving you an option to have some level of associativity there as well. And I will
and share, but yeah, I think a lot of companies typically tend to choose model weight being more important, which means that they're sacrificing the associativity piece, which often means that they're waiting to do operations with skeleton models later in the design process when things aren't changing as much, which can cause its own bucket of issues. So yeah, Ben's going to show how we can kind of help give you the best of both worlds here.
Absolutely. So back to our same electrical rack model here. I'm going to open the copier this time. And another nice feature of our platform, of this tool, is just in the tools dropdown, we have an option to create subassembly. So now I can give it a name and it's going to say, do I want a harness part? This is because a lot of times, like Phil mentioned earlier, we see people using these skeleton models and copy geometries in terms of routed systems. It absolutely doesn't have to be used that way. So we can choose not to create that harness part if we're just using this for large assembly management. I'm going to go ahead and say yes in this case, though. What that's going to do is now create a subassembly in our model with a contained skeleton and a harness part. all created inside of it. We can see that right now the skeleton, it's empty. It just has our starting features, 3 default planes and a default coordinate system. But now what I'm going to go do is I can choose any level of this assembly as my equipment assembly. This is where are the references that I want to create copies of. I'm just going to middle click off in space here. When I do that, it's going to default to the top level assembly. So we should see that pop in here. Right now, what's happening is it's actually scanning the entire model tree and finding all of the published geometry features that exist in any of the models in this assembly. Next thing I want to do is select my skeleton. This is our target. Where do we want to create our copy geometry features? And we want to do that inside of our skeleton model. So if I expand open, this is the same model that we were looking at with the published geometries earlier. And you can see we have a list of coordinate systems, J1 through J5, surface groups. There's our mounting surface published geometry. This is where what Phil had mentioned way back at the beginning, the kind of crawl, walk, run to this, the establish things from the beginning, build a good foundation, well built out models with a lot of data in them. We can go and leverage these things later. So now I can go and because I have these published geometries, I can just create a copy geometry of this individual coordinate system. I can choose the entire group of coordinate systems. I can do this from the part level, or I can do this from the assembly level. So in order to really show where we could get this in the finalized state, I'm going to just go to the top level of my assembly, and I'm going to assume that all of our models are set up with published geometries that are thought out at the library part level. We know these are the things that are going to be important. So I can now come in here to the top level and just say copy all children. And this is going to go and build out a copy geometry feature per published geometry feature that exists in the model tree. And we can see it's doing a lot because this scroll bar is getting quite a bit smaller here. So we'll let that run for just a second. Now it's done. Now we can see all of this stuff populates on the right side of our tree in our skeleton. And if I scroll through the list, you can see just how many all external copy geometries we just created, right? Probably over 100 here. I haven't counted, so I don't know exactly, but somewhere in the triple digits most likely is what we just created in just a matter of seconds there. One last nice little feature here. This is not that big of a model. You may get a model a lot bigger than this with a ton of copy geometry features being created. So in the tools drop down again, fix copy geometry groups. Just groups them all up by component. Makes it a little bit easier for you, if you're scrolling through that tree. So now the question is, I had mentioned earlier, I'd kind of teased what we've brought to the table in terms of making these external copy geometries more associative. So let's look at this box 101. We can see all those copy geometries came in. They're all in the right place. That's great. But what if I come in here and might need to activate this. Yeah. Let's say I move this component, and let's just put this way off in space so that it's obvious. All right, so what happens now with our copy geometry features? If we go back to our box 101, we can see they have not updated. All right, so this is actually going to be more similar. It's going to mirror kind of the functionality of manual update. If I go back into the CADactive tab, we go to the copier, we will collect all of our references again. Now we have our skeleton. And I'll move this off in space. Let's expand here. There's our box 101. If I select, we can see there's the component placement coordinate system. This is why all of those copy geometries are located in this spot. It's also the difference between assembly context and external copy geometries is the fact that you need this coordinate system. And it's Side note, also the reason that external copy geometries are more lightweight than assembly context copy geometries. But anyways, if I right click on this box 1, we have an option to update location. Now that I do that, if I click back on box 1, we can see, because of some pretty cool stuff that we're doing behind the scenes, we're able to recalculate the position that that coordinate system should be in, even though it has no reference to this box whatsoever. And now, if I go back to my skeleton, all of my external copy geometries have snapped into place. So there's that level of associativity that we have. And with 6 minutes left here, I think I've got enough time to go ahead and show where this could really lead ultimately, and some of the cool stuff that we can do with this. So if I open up my routing demo subassembly now, if I turn on my coordinate systems, now you can see there's all those copy geometries, right? There's a lot of them. But if I turn that off, really the ultimate goal here, like Phil had mentioned, is we want to build models from Excel, right? We want to automate processes. So the final piece that I'll show before opening the floor to questions is AutoAssemble. So here we have an input file that I'm going to have to browse to. And now we can see down below, here's a bunch of different models with designations that, because of all of our copy geometries, really to flow through the whole thing, because of our published geometries, we're able to create all of our copy geometries in one click, right? Fully build out this robust skeleton. And now that we have a robust skeleton in common naming conventions, I'm able to use this NWF file. This is something we can format as an export from some other tool, maybe a 2D schematic tool. And when I hit OK.
And Joey, I think that starts to hint at the question you just posted in the chat, where we're talking about ECAD, MCAD collaboration, right?
Yep. Yeah, absolutely. Absolutely. So there is native ECAD, MCAD collaboration between Creo schematics and Creo parametric. Obviously, there's an XML export that we can then bring into Creo parametric, import, and use all of that information, leverage that information inside of Creo parametric. We actually offer solutions to do that even if you are not using Creo schematics. We have created some bridges from other 2D schematic tools into Creo parametric so that you can leverage that information. There's also, we have some built out. There's obviously a lot of tools out there. So if you use something that we don't have a bridge for, we'd love to talk to you about what that looks like to build one out so that you can really take advantage of the work that you've done on the schematic side when you come to the 3D model. But back to this, our AutoAssemble, you can see, has brought in all of these different connectors. Not only that, it's assembled back shells to connectors that were assembled with AutoAssemble. It's also created a bunch of these point features, which is just to show that we can do more than just assemble. We can kind of add other operations into that as well. But if we switch back to the top level, bam, there you go. You can see everything is in the right place because we have our copy geometries all located. Even this box that I had moved, just so that you know there's no funny business going on. We moved this box, we updated our copy geometries, everything came in the right place. So yeah.
Guys, yeah, we've got like 3 minutes. Are there any questions? I'd like to wrap up.
Yeah, Ramil asked, well, I think when we were moving this component, if it would do the same if we just regenerated the assembly. And I think if we're using external copy geometries, the answer to that is no.
Correct. Yeah. Because, and I can actually show this again. Let's move this box back. It's like 4.5 or something like that. There's our okay. If we go and regenerate, nothing happens, right? And the reason is this component placement coordinate system, because external copy geometries are lighter weight, this has no reference to this box at all. No link to it. That's how these are more lightweight. What we've done is kind of, it's actually through a parameter, really. We do some cool stuff behind the scenes, like I mentioned earlier, that allows us to then go and do the update location. But once we do that, we'll see everything snap back into place here.
Rebecca posted a question. What does removing the skeleton from this assembly do to the copy geometries in a skeleton? Removing the skeleton from this assembly.
So if we remove this skeleton is what contains all of these external copy geometries right now. So if we delete the skeleton, we are deleting all of the copy geometries as well. So they would all be gone. And because we are assembling all of our connectors to those copy geometries, now we would have problems, right? So that's that's not going to be a good thing if we go and delete that skeleton model, but it's no different than the way that you would normally work with Creo. So now I did my update location. Now when I regenerate the model, everything snaps into place.
But that's after you run that CADactive magic.
Yes, that's after the CADactive update location for the external copy geometries. And side note here, this is the way we have it set up right now. I know it's noon. If anybody needs to jump, please feel free. Well, noon mountain. This is the way we have it set up right now to be this kind of more like manual update process using external copy geometries. That's not to say that we can't use this in different ways, right? We could set this up for your company to use assembly context with automatic update. We could set up a listener that goes and updates location of everything that's been moved when you regenerate or when you save or when you check in. There's all sorts of different opportunities here. So just because it's the way it is right now doesn't mean it's the way it has to be. It's not stagnant. We're pretty flexible.
Thank you all so much for spending some time with us today. We genuinely appreciate it, and we hope that we can have conversations with all of you. Some of you are familiar faces, and thank you so much, Deb, for including us and giving us a shot to walk through some of this stuff.
Thank you. I'm always amazed you guys take on such big models and just think that something's going to blow up and everything just goes real smooth. It's pretty cool.
That's the idea.
I know, it's great.
Love it.
Thanks, everybody. And like I said, hopefully this recording will work and then it'll get posted later today. And we also have been putting it on the BadgerUG user group YouTube. That'll probably take a couple of days. So sometime if you're bored, look at BadgerUG user group YouTube channel. Thanks, everybody.
Thank you, everyone.
Yeah, really appreciate the time.
Appreciate you guys. Thanks.